Today you will learn how to add and subtract conformable matrices and to multiply matrices by a scalar. You will also learn what the identity matrix is and how it is used. A conformable matrix is one where the dimensions are suitable for the operations that are being applied. A matrix is an array of numbers or expressions, and it's just an extension of column vectors, so you will already know how to add, subtract and multiply vectors, and therefore you should be able to then apply the same rules for matrices. Let's take a look at a matrix. So this is the matrix A, and we can describe the order of a matrix by looking at the number of rows and columns that it has. So if we take the number of rows and the number of columns, we would say that the order is 3 by 2. Let's take a look at addition and subtraction of matrices. You can only add and subtract matrices if they have the same order, which will become apparent with this example. Here is matrix A and B, and if we are to add together matrix A plus B, we need to add together the elements that appear in the same position. So we are going to add the 12 and the 6 together, 8 and minus 3, 0 and 3, minus 3 and minus 4, minus 1 and 5, and then the last one there, 5 and 0. So the solution would look like this: 18, 5, 3, minus 7, 4 and 5. The 18 comes from 12 plus 6, 5 comes from 8, take away 3, and so on. Let's take a look at multiplying a matrix by a scalar. This can be done to any matrix. So if we take that matrix A again, and we want to work out 3 lots of A, we multiply each element of A by 3. This is the answer. 3 times 12 gives us 36, 3 times 8 gives us 24, and so on. Now the same is true backwards as well, so if we wanted to take a factor out, we could do that, but it would have to be a factor from each element of the matrix. Okay, now here's one that you can try. Matrix A and B are given. See if you can work out the value of 2A minus B. Okay, the first line would look like this: 2 lots of A, take away B. We then multiply the scalar 2 through matrix A, and then we subtract the second matrix from the first. Now we're going to take a look at how to transpose a matrix. The transpose of a matrix is when the rows and columns have been swapped, and it's denoted by a T. So if we were to transpose the matrix A, we would write that as A superscript T. Here is A. Here is A transposed. Notice that the first row of A becomes the first column of A transposed, and the second row of A becomes the second column of A transposed. Similarly for B, the first row of B becomes the first column of B transposed, and the second row becomes the second column. Now, if we have 2 matrices A and B with the same order, then if we were to find A plus B and then transpose the answer, we would be able to check that is the same as A transposed plus B transposed. You may wish to have a go at this yourself. Just choose 2 matrices for A and B and add them together, and then transpose them and see if that does work out to be the right hand side. Okay, and the last thing for today's lesson is to look at something called the identity matrix. This is a square matrix where the leading diagonal is made up of 1s and all of the other elements are 0s, and it's denoted with an I. So if we have a 2 by 2 identity matrix, it would look like this. So notice the leading diagonal here made up of 1s and every other element is 0s. And if you look at the 3 by 3 matrix, similar again, so we have a leading diagonal made up of 1s and all of the other elements are 0. Please turn to page 141 and complete exercise 7a.